So see this lecture. In this lecture we have discussed the parameter of operational amplifier. Part number 2. This is the part number 2 lecture. Voltage gain, offset current, offset voltage, bias current, that we will be discussing in the lecture. Now see, what is the meaning of, so today we have discussed the parameter of operational amplifier. Parameter of operational amplifier, voltage gain of Opamp, V0 divided by V in. See this equation. So it is known as AV. So voltage gain and very less, input is very less, amount of signal, very less amount of signal that can be applied to operational amplifier. So ideally voltage gain of operational amplifier is infinite. Ideally voltage gain of operational amplifier is infinite, and practically it is known as 2 into 10 raised to 5. So small value, then our voltage gain equal to high. So it is known as voltage gain of amplifier. See this input that can be applied to differential amplifier V1 minus V2. Input that can be applied here. See this, I have drawn the figure. See this, here V1, here V2. See this carefully. V1, V2 that can be applied to the input of amplifier. Now, V1 minus V2, which is known as differential voltage, which is very less. That's why voltage gain of amplifier is very high. Now, offset voltage. Offset voltage means what? If AC signal is not applied to the inverting and non-inverting terminal of op-amp, or inverting and non-inverting terminal, inverting and non-inverting terminal that can be connected with ground, still we can get output voltage. Then this output voltage is known as offset voltage. This output voltage is known as offset voltage. See this. Here it can be connected with grounds, then we can get still output voltage which is equal to 2 millivolt. This output voltage we can get, this output voltage is known as error or noise voltage due to presence of DC supply. See this DC supply. Due to presence of plus VCC and minus VEE, we can get this type of voltage which is known as output offset voltage, or we can say also it is known as noise voltage. If we want to nullify this output or make output voltage equal to 0, so we can apply the amount of DC input voltage, so get 0 output. We can apply the DC voltage in such a way that we can get the 0 output. So this voltage is known as input offset voltage. So this voltage is known as input voltage or input offset voltage. See this voltage that can be applied as an input. So it is known as input offset voltage. See this figure very carefully. Here output voltage which is equal to 0. That's why it is known as input offset voltage. And what is the meaning of input offset voltage? Compensating network. One potentiometer that can be connected at the pin number 1 and pin number 5 of operational amplifier. At that time we can get the output voltage which is equal to 0. See, I have right here output voltage which is equal to 0. That's why it is known as input voltage compensating network. That's why it is known as input voltage compensating network. And here we can apply the circuit in such a way that we can get the output voltage equal to 0. That's why it is known as input voltage compensating network. So toe parameter of op-amp, voltage gain and offset voltage, they we have discussed here. What is the ideal value of voltage gain which is equal to infinite? What is the practical value of voltage gain which is equal to 2 into 10 raised to 5? Why? Because if very less amount of input that can be applied to the op-amp in terms of microvolt, then microvolt which is known as 10 raised to minus 6. See this microvolt that can be act as a 10 raised to minus 6. See this, I have right here V0 divided by 10 raised to minus 6. So here we can get V0 into 10 raised to plus 6. See this, which is known as voltage gain of amplifier, which is always large as possible. And what is the ideal value of offset voltage? Ideal value of offset voltage is 0, and practically it is 2 millivolt. Practically output offset voltage in output for offset voltage and input offset voltage, it is 2 millivolt. Now output offset current. Due to output offset voltage, what is the amount of current that can be flow in the circuit? It is known as output offset current. Ideally it is zero. Ideally it is zero. And what is the bias current? Bias current means what? If two terminals that can be applied as an input, and what is the output current in terms of difference? In terms of difference current that we can get at the output. Here, which is known as IB1, here it is known as IB2. So ideally IB1 minus IB2, or we can say IB2 minus IB1, which is known as bias current, which is known as bias current. Now I have draw one table which indicate all the parameter whatever discussed up till now. See this. First of all, which is known as serial number, parameter. Here we can say consider parameter. Here consider ideal value and practical value. Now see, first parameter, which is known as input resistance. Input resistance. Ideally, input resistance is infinite, and practically 1 mega ohm. Second, output resistance. Ideally 0, practically 75 ohm. Why? Because if output resistance is low, then more amount of load that can be connected. Output resistance. Third, which is known as voltage gain. Ideally infinite, practically it is 2 into 10 raised to 5. Here it is known as ideal value. Here it can be considered as a practical value of Opamp. So here it is known as basic diagram of Opamp parameter. Of Opamp parameter basic diagram. Now another page that I have mentioned here, which indicates the another parameter of Opamp. Here serial number, here parameter, here ideal value and practical value. What is the next? Offset voltage. Offset voltage, ideally 2 millivolt, practically 2 millivolt, ideally 0. It is considered as an ideal value. It is considered as a practical value. So it is known as offset voltage, offset current and bias current. Offset current, ideally 1 microampere, ideally practically 1 microampere, practically 1 microampere and ideally 0. See this. This is offset current. So this is the parameter of Opamp that we have discussed here. Uh, second part of my lecture, parameter of Opamp. In third part of lecture, I will explain the another parameter of Opamp, which is known as slew rate, PSRR and CMRR. Thank you very much.